See, today we have to start here. The features of the reversible process. There are four features of the reversible process. First, features of reversible process. That reversible process, in last lecture we have to study that opposing force is slightly greater than driving force. We have to call it as the reversible process. Then there are four features for the reversible process. First feature of reversible process, there is small difference in the driving and opposing forces. Then second features of the reversible process, that will be the smaller change in the condition, that reaction it will be reversed. Third, that will be take place in number of steps, and each step having equilibrium it will be attained. That will be mechanical equilibrium attained. These are the four features of the reversible process. Then we have to study here the nature of heat and work. 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 See, first we have to study here the nature of work. Nature of work. Nature of work. That will be the W have to study here. Nature of work. See, the nature of work that will be explained in terms of the force by displacement. That W is equal to here. Means any body they have displaced by a distance d, and that force means F into d. They have explained in terms of that work. See, here we have to study that in thermodynamics we have to study the nature of work. That will be the pressure volume type of work. Pressure volume type of work. That will be the PV product. Pressure volume type of work. See, the PV product. Here the pressure means the force per unit area into volume. That area it will be in terms of the d, that will be the d square, and in volume that will be d cube. D cube. Then one object it will be cancelled, that F into d, and it will be the work. See here the nature of work. That will be the any body they have displaced the distance d through a force F, and W is equal to F into d. In thermodynamics, they have given the pressure volume type of work. That will be the pressure is force per unit area into V. Then that area that in terms of d square, that d cube, that will be cancelled, and you have to get the pressure volume type of work is equal to F into d. That will be explained here. Then the decomposition of H2O2. See, or to study the work, or to study the nature of work, and that will be give the two examples. That will be first, or to study here the work. First, decomposition. Decomposition of H2O2. Decomposition of H2O2. That reaction they have explained here. Decomposition of H2O2. That will be the H2O2. They have used the H2O plus O2. Twice H2O, 2H2O2. Means here that will be the oxygen, it will be the removed. In that reaction they have the expansion of that H2O2. That process is the decomposition of H2O2. It will be happen. Means here that system. Means here two uploaded system, that will be the expansion. In diagram they have given. Means here or to fill up the H2O2, that will be expand. Here that level it will be changes, because it forms the H2O and O2 from the H2O2. That's why it's twice H2O. That will be given here. Means here that gas it will be the expansion. That process it will be the expansion process. That process is the expansion process. See the decomposition. Means here that the system lost the energy. System lost energy. Here system it will be lost the energy, and it will be loss energy need to go to the surrounding. It goes to the surrounding. Means here work done by the system. Work done by the system. Means here that expansion it will be happen. That system it will be lost its energy and that expansion it will be happen. Means here the system work done. That W it will be work done by the system. By the system on surrounding. On surrounding. Work done by the system on surrounding. Here system lost the energy. System lost the energy and go to the surrounding. That will be what to call here the system lost the energy. That will be the loss of energy by the system. Means the work done by the system on the surrounding. Work done by the system on the surrounding. And second example for work, they have given the reaction in between the NH3 and HCl. The reaction between NH3 and HCl. Second example, reaction between NH3 and HCl. Reaction between NH3 and HCl. See here, to fill up in cylinders that NH3 and HCl. First, that will be here. It forms means the reaction NH3 plus HCl it gives rise to NH4Cl, and that will be in solid phase. Here it will be in gaseous phase. Means here solidification it will be happen. See here that NH4Cl that solid it will be formed. Means from that level it will be decreases. Means here the compression. Means here that it will be the compress. It will be the compress. Means here system that will be gain the energy absorb. Means opposite to that. Opposite to that, here the reaction between NH3 and HCl that results that decrease the height of that cylinder. Means here solidification that process NH4Cl it will be prepared. Here surrounding loss energy and system gain. Means surrounding loss energy. In that reaction surrounding loss energy. Surrounding loss energy. Okay? Compression it will happen. That surrounding loss energy. Means work done. कोणाकडून होईल? First to system loss energy, then work done by system. Here opposite to that. Means here that work on the system. That work on the system. Means here that will be the pressure volume type of work. We have to call here that the work done by the surrounding on the system. Work done by surrounding on system. Opposite to that. Because here surrounding loss energy. Surrounding loss energy means work done. That by surrounding on system. By surrounding on system. Means these are the two examples. That expansion and compression of the gas. That decomposition of H2O2 and the reaction between NH3 and HCl. The reaction between NH3 and HCl. They have give the two ways. Then the nature of heat. Heat is a form of the energy, and that the system exchange energy with its surrounding. They have give the different ways that loss energy, gain energy, and they have explained the sign convention of the W and Q. Sign convention of W and Q. See here the sign convention of W and Q, because here we have to study the two reactions, that compression and expansion, that W and Q. W and Q. That Q, here W it will be the negative, W it will be the positive, here Q it will be the positive and Q it will be the negative. These are the sign conventions. Here W work done it will be the negative, that gas it will be the expansion. Means here the system it will be work. that work done by the system on the surrounding. That will be explained here. Work done by the system on the surrounding. Then plus W. It will be the opposite to that. It will be the opposite to that. Plus W means work done on the system by the surrounding. Here work done on the system by the surrounding. And heat change, that will be in terms of, you have to heard the word exothermic endothermic reaction. That way, that heat is absorbed by the system plus Q. Heat is absorbed by the system from the surrounding is plus Q, and heat is released by the system. It is released by the system to the surrounding. It will be the negative, like the exothermic and endothermic reaction. These are the sign convention of W and Q.